Inverses. Today we're talking about inverses. All right. Inverse trigonometric functions, inverse trigonometric expressions, determining an inverse. This is a section that for some reason really eats up students, and I think I know why. We've got to know the prerequisite skills for this. If I say, what is the tangent of a 45-degree angle, and you have to think more than 1 second about that, then you're not seeing the wind. So make sure a tangent of a 45-degree angle. First thing that pops in my mind is a 45, 45, 90-degree right triangle where the sides are 1, 1, square root of 2. So tangent, some old hippie called another hippie, tripping on apples, that is opposite over adjacent, is 1. And then the same for sine and cosine. But not only do we have the two special right triangles, which are really beneficial in determining these trigonometric ratios, but we also have the unit circle, which is nothing more than taking those special right triangles and shrinking them down so that the hypotenuse is equal to 1, and then we get those 16 ordered pairs. And also we have the graphs of the trigonometric functions. So, the perspective of looking at these trig ratios from the perspective of a circle or a triangle, all this should be bouncing around in our mind. And we should know these. We should be able to see the sine of a 60-degree angle. The sine of a 60-degree angle. We should see that 30, 60, 90-degree triangle. Or we should be looking at 60 degrees on the unit circle. What is that ordered pair? It's 1/2 square root of 3 over 2. How do I remember this? Well, you have to practice it a little bit. Trig is like playing the piano. It's not like algebra. Trig, there's some fundamental things that we just have to know and understand and look at and play with. And the more you know these facts, it is such a beautiful, beautiful branch of mathematics. And it's only a tiny, tiny little branch of mathematics because, if I were to take a football field and walk out there and say, well, how much of this football field is encompassed by trigonometry? You probably wouldn't barely see the little spot I'm standing on because there's so much mathematics out there. So before we get into these inverse trigonometric functions and ratios, let's just go back and talk about inverses. So just as a brief review from algebra, the inverse of the ordered pair 2, 4 is 4, 2. That's it. And you may actually start going, what about the inverse of y equals x plus 3? Well, since the inverse, we switch the x and y's, I'm going to do the same thing here. I'm going to switch the x and y's around. I'm going to subtract 3 and, write it as y equals x minus 3. And deep down, we knew that the inverse of adding 3 to a number was subtracting 3 from a number. So, if I were to plug in the x value 5, 5 take away 3 is 2. So if 5, 2 is in this linear equation, then the ordered pair 2, 5 should be in this one. And it is. 2 plus 3 is 5. So the inverse undoes. The inverse of adding, subtracting, the inverse. But we got to be a little careful with that. Because, like I said, the inverse of 2, 4 is 4, 2. And those two ordered pairs are reflections of each other across the linear equation y equals x. So when we start graphing exponential functions and look at the logarithmic functions from algebra, they were reflections across that line y equals x. So very, very cool. But in order for a true function, and we're just going to keep it with that, to have an inverse, it must be 1 to 1. It must pass the horizontal line test. So you might be asking yourself, well, I remember the vertical line test. Well, that was to determine whether something was a function. The horizontal line test is to determine whether something's 1 to 1. And what I have here is f of x equals x squared, which has a domain of all reals. But we have to be a little careful, because intuitively we know that taking the square root of something is the inverse of squaring something. I mean, we're not going to argue about that. But this is where we have to be careful. If I look at this graph, I know that I have the ordered pair maybe 2, 4. I also have the ordered pair negative 2, 4. So and I look at the inverse of f of x equals x squared, I would think, well, the inverse of squaring is definitely, well, let me do it like I did up above. F of x is the same as y, so y equals x squared. To find the inverse, I switch these around and get x equals y squared. I take the square root of both sides, and I get the square root of x equals y, which is the graph of, let me use a different color, would be this graph right here, which is a reflection of this piece of it across the line y equals x. Now, I'm not getting into the plus or minuses or the principal roots and so forth, but I'll just say this. When we look at y equals the square root of x, how do I get, if I plug in 4, I get 2. So the ordered pair, 2, 4 is on f of x equals x squared. The ordered pair 4, 2 is on this graph. But the problem is, how do I get 4, negative 2? And the answer is I can't. So, quite frankly, the graph of y equals x squared is not one-to-one. It does not pass the horizontal line test. In other words, when I draw a horizontal line across this, it hits it twice, which means that it is not one-to-one, and we got to be really careful when we start talking about these inverses. So to keep this conversation simple, and I'm leaving out a lot of little pieces here, so those of you watching this video that are deep down true mathematicians, you might be nitpicking it a little bit, but this video is not intended for you. So, what I want to do here is recognize that, well, what can I do? Oh my gosh. Well, I do what they did in the horror movie by Wes Craven, The People Under the Stairs. If somebody has an attribute I don't like, let's get rid of it. And then they'll be the perfect little boy. So, let's get rid of this. I cut that little piece off. And what I do is I restrict the domain of f of x equals x squared to a domain that is just from 0 to infinity. The part that is left will pass the horizontal line test. The part that is left is one-to-one. And now the ordered pair 2, 4, which is on this function, is also 4, 2, and all the other points as well. So everything is perfect now. So we restrict the domain, which should automatically go, wait a second. All of our trigonometric functions are not one-to-one. Every single one of them fails the horizontal line test. So what we do in trigonometry is pretty much what we did in algebra. We restrict the domain, which here is all reals. We restrict the domain here, which the domain is all reals. And we restrict the domain here, which the domain is not all reals because we have these asymptotes. But, here's what we're going to do. We're going to snip away the parts that we don't want. We're going to make these functions one-to-one. In other words, if I get rid of all of this, and then get rid of all of this, wow, that is one-to-one. So the inverse, I want to be careful here. This is not the graph of the inverse sine function. It's the graph of the sine function where the domain has been restricted to negative 90 degrees to 90 degrees. I want to be very clear on that. Right here for cosine, I'm going to restrict the domain here. I can't do it the same way I did there because it still wouldn't be one-to-one. So what I'm going to do is I'm going to restrict it. I'm going to get rid of all that, and I'm going to get rid of all that. So now, our cosine function is instead of all reals for the domain, we restricted it down to 0 degrees all the way up to 180 degrees. And last but not least, we're going to do the same thing for tangent. I'm going to get rid of all of this and get rid of all of this. And what I've done is I've restricted the domain of the tangent function to the same as the sine one up here, negative 90 degrees to 90 degrees, which is very awesome. This is what I recommend that you burn into your memory. And it's not learning anything new. It's learning the sine, cosine, and tangent function, and we're just restricting the domains down to these intervals right here. So, now these are one-to-one. We can talk about the inverses. And let me show you why this is kind of cool. What is the inverse sine of 1? Or some textbooks or videos might say, what is the arc sine of 1? Same thing. Now you're sitting there going, okay, I've got to know this. I've got to figure this out. This is tough. No, it's not. Answering this question is the same thing as answering this question. The sine of what equals 1? Now think about it. What angle gives us a sine that's equal to 1? And if you want to, we could sit here and look at the unit circle, or you could say, I'm looking at the picture right there, Daniel. It's, the sine of pi divided by 2 radians is equal to 1. Exactly. This is the graph of the unit circle, which is weird that I'm drawing the unit circle, but stay with me. Here's the unit circle. So remember, this is the ordered pair 1, 0. This is the ordered pair 0, 1. This is the ordered pair negative 1, 0. This is the ordered pair 0, negative 1. Who are you? Boop, 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 boop. So CSI, we're not going to deal with imaginary numbers right now. So it's the y value that's the sine. So look at that. Blau. At 90 degrees, pi divided by 2 radians. So the answer to this is 90 degrees. But wait a second. We could also go around here to 90 and then do another 360 to it. So that would be the sine of 360 plus 90, which is 450 degrees, is also equal to 1. And then we could add another 360 to it. Or I could go here and go this direction, negative 270 degrees. The sine of negative 270 degrees is also equal to 1. So you're sitting there going, so there's more than one answer to this, because the sine of 90 is 1, the sine of 450 is 1, the sine of negative 270 is 1. No, there's only one answer. Our answer for this inverse sine of 1, the arc sine of 1, is only 90 degrees. It must be this one, because 90 degrees is right here. In other words, remembering about inverse functions, the domain of x squared is now the range of this. Notice how 2 is x, that's the domain, now it's the range. And the range of this is now the domain of that. So, what happens here is we restricted our domain from negative 90 to 90, which means that our range of the inverse function better be between that interval. You know, watching this video one time and while you're eating your sandwich or texting or playing Cookie Jam or Slither.io, that ain't going to do it. You need to watch this video several times. I recommend 3 or 4 times until you memorize every beautiful feature of my face. And yes, I do need a haircut. And everything that's up here. And keep in mind one thing. When you're dealing with inverse sine or arc sine, which is inverse sine, inverse cosine, inverse tangent, your answers for these should be in the range of these restrictions to the domain. Inverse tangent, inverse cosine, inverse sine. This can be kind of hard. Watch it again.